USS Preble DDG-88 unveils cutting-edge HELIOS laser weapon, a game-changer in naval warfare. Overview. On February 4, 2025, the USS Preble DDG-88, an Arleigh Burke-class destroyer of the U.S. Navy, showcased its state-of-the-art HELIOS high-energy laser with integrated Optical-dazzler and surveillance laser weapon system. This unveiling marks a significant milestone in the evolution of naval warfare, representing a transition from theoretical concepts of directed energy weapons to their practical application in military operations. Developed by Lockheed Martin, HELIOS integrates several advanced capabilities that promise to revolutionize naval defense strategies. Key features and capabilities of HELIOS. HELIOS is a multifunctional system that combines a high-energy laser for target destruction and optical-dazzler to disrupt enemy sensors and advanced surveillance features. Initially operating at a power level of 60 kilowatts, HELIOS is designed to scale up to 120 kilowatts, allowing for flexible operational adjustments based on mission requirements. The system's ability to deliver virtually unlimited firing as long as a power source is available relieves logistical pressures typically associated with conventional munitions, enhancing the operational endurance of naval vessels. The system can perform both hard kills destroying targets and soft kills disabling enemy systems, effectively countering modern threats such as drones, fast attack craft, and potentially short-range missiles. Its integration with the Aegis combat system allows for coordinated defense measures, significantly enhancing the effectiveness of naval operations. Development timeline. The HELIOS program commenced in 2018 when Lockheed Martin was awarded a $150 million contract to develop, manufacture, and deliver two systems, one for land testing and another for naval integration. Key milestones include 2018, award of the contract to Lockheed Martin. 2020, the system passed its critical design review, paving the way for subsequent testing phases. 2021, sea trials began at Wallops Island, Virginia, with the USS Preble becoming the first naval vessel to be equipped with HELIOS. 2024, following rigorous testing, HELIOS demonstrated successful engagement with unmanned aerial targets, validating its operational readiness. Testing and operational readiness. Extensive testing has been conducted by the U.S. Navy's Center for Countermeasures (CCM), which oversaw 32 test events in fiscal year 2024, evaluating HELIOS's capabilities against aerial threats. These tests confirmed the system's functionality and guided further refinements. Nevertheless, challenges persist related to power generation and atmospheric conditions that may impact laser effectiveness. Global context and competitors. The advancement of laser weapon systems is not exclusive to the U.S. Other nations, including Israel Iron Beam, South Korea Block I, and the United Kingdom Dragonfire, are also investing in similar technologies, indicating a global arms race in directed energy weapon capabilities. These systems are designed to counter a variety of threats, emphasizing the necessity for military technology to evolve in response to emerging challenges. Commonalities and differences in sources. All sources highlight the transformative potential of HELIOS in naval defense, particularly its multi-mission capabilities and integration with existing combat systems. However, variations exist in details such as development timelines, specific capabilities, and the extent of operational tests. Some sources focus on technical specifications while others emphasize visual documentation of HELIOS in action. Conclusion. The integration of the HELIOS system aboard the USS Preble signifies a pivotal advancement in naval warfare, offering enhanced capabilities against contemporary threats. As the U.S. Navy expands the application of directed energy weapons across its fleet, the implications for future naval strategy and international military competition are profound. The race to harness laser technology reflects a significant shift towards more sustainable and technologically advanced defense solutions in an era characterized by complex and asymmetric threats. Additional insights. The HELIOS system is emblematic of a broader military strategy aimed at developing cost-effective defense solutions. Its deployment is expected to reshape naval strategies and provide the U.S. Navy with a substantial edge in maritime operations. The ongoing global investments in laser technology by various nations suggest that the future of warfare may increasingly rely on directed energy systems to counter evolving threats effectively. References 1. Source 1. Army recognition. U.S. Navy transforms naval protection with Helios lasers. /armyrecognition.com/news/Navy news/2025 US Navy transforms naval protection with Helios lasers. Power on USS Preble at sea. 2. Source 2. Bulgarian military. USS Preble fires Helios lasers. /bulgarianmilitary.com/2025/02/03/ USS Preble fires Helios laser in stunning US Navy photo. 3. Source 3. The Sun Navy Helios laser drone warships. /www.thesun.com/news/134455559/ Navy Helios laser drone warship. This report encapsulates the significance of the Helios system and its potential impact on naval warfare. Summarizing the technical, operational, and strategic dimensions of this advanced weaponry. The integration of the Helios high-energy laser with integrated optical-dazzler and surveillance system aboard the USS Preble DDG-88 signifies a transformative moment in naval warfare, showcasing a shift from traditional kinetic weaponry to directed energy solutions. The Helios system represents a multifaceted approach to modern combat, combining various capabilities that challenge conventional perceptions of naval defense systems. Counterintuitive aspects of Helios and its deployment. 1. Unlimited firing capability. One of the most striking features of the Helios system is its ability to fire continuously as long as power is available, which contrasts sharply with traditional munitions systems that require logistical support and resupply. This seemingly straightforward advantage actually complicates military logistics and strategy in unexpected ways. While the capability reduces dependence on conventional ammunition, it raises issues regarding power management aboard naval vessels. The sheer demand for electrical energy to operate high-energy lasers like Helios may necessitate significant upgrades to existing naval power generation systems, which could divert resources from other critical areas. 2. Soft kill versus hard kill. The dual functionality of Helios, allowing for both hard kill physical destruction and soft kill disruption of enemy sensors, introduces an interesting dilemma in targeting and engagement protocols. This counterintuitive aspect suggests that not all threats might warrant destruction. The strategic decision-making process becomes more complex as commanders must evaluate when to disable a threat versus when to destroy it outright. This could lead to contentious debates regarding engagement rules in combat scenarios, potentially complicating operational effectiveness. 3. Testing against atmospheric conditions. While Helios has shown promise in engaging unmanned aerial targets, the effectiveness of laser systems can be significantly impacted by atmospheric conditions, such as fog, rain, or dust. This counterintuitive limitation highlights a critical aspect of laser weapon technology that is often overlooked in discussions of its advantages. The reliance on clear weather for optimal performance challenges the perception of laser systems as a panacea for all aerial threats, pushing military planners to consider environmental factors in their operational readiness assessments. 4. Global arms race in directed energy weapons. The development of Helios is part of a larger trend in which multiple nations are investing in laser weapon systems, creating a competitive landscape that could lead to unforeseen consequences in international military dynamics. Countries like Israel, South Korea, and the UK are developing their own systems, which may lead to a rapid escalation in military capabilities and an arms race. This trend is counterintuitive in the sense that while laser systems promise cost-effective solutions, their proliferation could trigger a rearmament cycle that increases overall military spending and tension rather than stabilizing international relations. 5. Integration with existing systems. The Helios system's integration with the Aegis combat system presents both advantages and challenges. While this integration enhances overall combat effectiveness by allowing for coordinated defense measures, it also raises questions about interoperability and the potential for system overload. As naval forces increasingly rely on complex networks of systems, there is a risk that integrating new technologies like HELIOS could introduce vulnerabilities or complicate command and control processes, contradicting the expected enhancement of operational efficiency. 6. The illusion of cost-effectiveness. Proponents of laser weapons often highlight their lower cost per engagement compared to traditional munitions. However, the initial investment required for the development, integration, and maintenance of high-energy laser systems like HELIOS may offset these long-term savings. Additionally, the need for enhanced power generation capabilities and potential upgrades to ship systems could lead to unforeseen financial burdens, challenging the narrative of cost-effectiveness that often accompanies discussions of directed energy weaponry. 7. Public perception and military policy. The deployment of advanced technologies like HELIOS can significantly influence public perception and subsequent military policy. As nations showcase their advancements in directed energy, there may be an expectation for rapid deployment and operational success. However, the reality of integration, testing, and refinement often takes much longer than public narratives suggest. This disconnect could lead to public disillusionment or pressure for premature operational deployment, complicating military strategy and readiness. These counterintuitive elements surrounding the HELIOS system underscore the complex interplay between technological innovation and operational realities in modern naval warfare. As the U.S. Navy continues to explore the potential of laser systems, the implications for future conflict and military strategy will be profound, challenging traditional notions of engagement, deterrence, and defense. The unveiling of the HELIOS high-energy laser with integrated optical-dazzler and surveillance laser weapon system aboard the USS Preble DDG-88 represents a transformative moment in naval warfare technology that many may overlook in its broader implications. Here are several significant points from the report that warrant closer examination. 1. Operational flexibility and sustainability. One of the critical aspects of the HELIOS system is its operational flexibility, especially its ability to scale power output from 60 kilowatts to 120 kilowatts. This scaling capability is significant as it allows naval forces to adapt to varying operational needs without being constrained by traditional munitions logistics. Conventional weapons require extensive supply chains and resupply operations, which can be severely limited in combat scenarios, especially in remote or high-intensity environments. The HELIOS system's functionality. Offering virtually unlimited firing capability as long as power is available alleviates these logistical constraints. This shift toward a more sustainable and efficient weaponry paradigm is noteworthy because it not only enhances operational endurance but also signifies a potential rethinking of naval engagement strategies. 2. Integration with existing combat systems. The integration of HELIOS with the Aegis combat system is another vital point that could be overlooked. Aegis has long been a cornerstone of U.S. naval defense, primarily focused on missile defense and threat engagement through conventional means. The addition of a directed energy weapon like HELIOS allows for a multi-layered defense approach, combining traditional kinetic responses with modern directed energy solutions. This integration is significant as it enhances situational awareness and response times against diverse threats such as drones and small boats, which are increasingly prevalent in modern warfare. The implications of this integration extend beyond immediate combat effectiveness. They suggest a future where naval engagements might prioritize technology-driven solutions over traditional firepower. 3. Countermeasures and asymmetrical warfare. The HELIOS system's dual capability for hard kills, physical destruction of targets, and soft kills, disabling enemy sensors, addresses the evolving nature of threats faced by naval forces. Many reports highlight the rise of drones and small agile attack craft as significant threats in contemporary conflicts, and the HELIOS system's ability to engage these threats effectively underscores its importance. The optical-dazzler component specifically designed to temporarily blind or disable enemy sensors adds a layer of strategic complexity that could be pivotal in reconnaissance and counter-reconnaissance operations. The significance of this capability lies in its potential to alter engagement rules and strategies, especially in asymmetrical warfare scenarios where adversaries might rely on unconventional tactics. 4. Global arms race in laser technology. The report outlines a global context where countries like Israel, South Korea, and the UK are developing their own laser weapon systems, highlighting a burgeoning arms race in directed energy technologies. This competitive landscape underscores the necessity for nations to advance their military technology in response to evolving threats. The implications of this arms race extend beyond military capabilities. They touch on geopolitical stability, defense spending, and international relations. Nations that successfully develop and deploy effective laser systems may gain significant strategic advantages, altering power dynamics in regional conflicts and global military engagements. 5. Challenges and limitations. While the HELIOS system is heralded as a game-changer, the report also alludes to the challenges it faces, such as power generation and atmospheric conditions affecting laser effectiveness. These challenges are critical to acknowledge, as they highlight the limitations of current technology. Understanding these limitations is essential for realistic assessments of operational capabilities and future developments in directed energy weapons. The acknowledgement of such challenges also emphasizes the need for continued investment in research and development to enhance the effectiveness and reliability of laser systems under various operational conditions. 6. Historical context and evolution of warfare. The deployment of the HELIOS system marks a significant milestone in the evolution of naval warfare, transitioning from theoretical applications of directed energy weapons to their operational use. This historical context is crucial as it reflects broader trends in military technology, including the integration of advanced systems that leverage precision, speed, and sustainability. The shift towards directed energy weapons signifies a potential paradigm change in how naval forces engage with emerging threats, which may redefine traditional concepts of naval power and engagement strategies. Conclusion. The HELIOS laser weapon system on the USS Preble represents a pivotal advancement in naval warfare with implications that extend far beyond its immediate capabilities. The operational flexibility, integration with existing systems, countermeasures against modern threats, global competition in military technology, and the acknowledgement of challenges are all critical facets that underscore the importance of this development. As military strategies evolve in response to changing threat landscapes, understanding these elements will be vital for comprehending the future of naval warfare and international military dynamics. The HELIOS system is not merely a technological advancement, it is a marker of the shifting landscape of military engagement that could influence naval operations and defense strategies for years to come. 1. Transformational military technology. The deployment of the HELIOS high-energy laser with integrated optical-dazzler and surveillance system on the USS Preble DDG-88 represents a significant leap in military technology. Unlike traditional munitions, HELIOS provides a virtually unlimited rate of fire as long as power is available, fundamentally changing the logistics and operational capabilities of naval warfare. This advancement marks a shift from theoretical applications of directed energy weapons to practical, battlefield-ready systems. The system's dual capabilities of hard kills destroying targets and soft kills disrupting enemy systems signify a versatile approach to modern threats such as drones and fast attack craft. 2. Integration with existing systems. The HELIOS system's integration with the Aegis combat system enhances its operational effectiveness, allowing for coordinated defense measures against various threats. This synergy not only increases the system's lethality but also improves situational awareness, enabling operators to respond more effectively to evolving threats in real time. The ability to integrate advanced technologies within existing military frameworks reflects a strategic approach to maintaining military readiness and superiority in an increasingly complex threat environment. 3. Global competition in directed energy weapons. The development of HELIOS is part of a broader global trend in military technology, with several countries including Israel Iron Beam, South Korea Block I, and the UK Dragonfire investing heavily in directed energy weapons. This competition underscores the urgency for nations to advance their military capabilities in response to emerging threats, particularly in the context of drone warfare and missile defense. The international arms race in laser technology not only highlights the potential for new strategic alliances and rivalries but also raises questions about the future of warfare in a landscape where directed energy weapons could become commonplace. 4. Challenges in future outlook. While HELIOS represents a groundbreaking advancement in naval warfare, challenges remain, particularly concerning power generation and the impact of atmospheric conditions on laser effectiveness. The U.S. Navy acknowledges these hurdles and is actively working to develop solutions, including enhancing shipboard power systems to meet the demands of high-energy weapons. The ongoing testing and refinement of HELIOS and similar systems will likely shape the future of naval strategy, influencing military planning and resource allocation as nations adapt to a new era of warfare characterized by rapid technological advancement and asymmetric threats. 1. Project Orion, 1950s to 1960s. Project Orion was a research and development project initiated by the United States in the late 1950s aimed at creating a spacecraft that would be propelled by nuclear pulse propulsion. The concept involved detonating nuclear bombs behind the spacecraft to propel it forward, enabling it to achieve speeds sufficient for interplanetary travel. Although it never moved past the conceptual stage due to concerns about nuclear fallout and the potential for militarization of space, it represented an ambitious leap in propulsion technology similar to the leap represented by laser weapon systems like HELIOS. 2. The Strategic Defense Initiative SDI 1983, announced by President Ronald Reagan. The Strategic Defense Initiative aimed to develop a sophisticated anti-ballistic missile system that would use ground-based and space-based systems to protect the United States from nuclear missile attacks. The initiative included research into various technologies, including directed energy weapons such as lasers. While the SDI faced criticism and was ultimately not fully realized, it reflects a historical precedent of utilizing advanced technology for national defense akin to the current developments in laser weaponry. 3. The Airborne Laser ABL Program, 1996 to 2010. The Airborne Laser Program was a U.S. military project that aimed to develop a high-energy laser mounted on a modified Boeing 747 aircraft to shoot down ballistic missiles during their boost phase. The ABL program faced numerous technical challenges and was eventually cancelled, but it marked a significant effort in directed energy weapon development. Similar to HELIOS, the ABL was designed to provide a new layer of defense against evolving threats, demonstrating a continued military interest in harnessing laser technology for operational use. Future outlook: the impact of HELIOS laser weapon on naval warfare. The recent deployment of the HELIOS high-energy laser with integrated optical-dazzler and surveillance system aboard the USS Preble DDG-88 represents a significant leap in naval warfare technology. As the U.S. Navy integrates this cutting-edge directed energy weapon, several predictions can be made about its future impact on naval strategy, defense capabilities, and the broader landscape of military technology. 1. Revolutionizing naval defense strategies. As HELIOS becomes operational, it will fundamentally alter naval defense strategies. The ability to engage multiple aerial threats with high precision and speed will shift the focus from traditional munitions to laser-based defenses. This capability allows naval vessels to defend against swarms of drones and small attack craft without the logistical burden of resupplying conventional ammunition, enhancing operational endurance during extended missions. 2. Expansion of directed energy weapons. The successful integration of HELIOS is likely to pave the way for broader adoption of directed energy weapons across the U.S. Navy and allied fleets. As operational tests validate its effectiveness, additional vessels will be equipped with HELIOS and more powerful laser systems like the 150 kilowatt laser weapon system demonstrator LWSD. This trend aligns with a global military shift towards leveraging cost-effective, sustainable technologies that can address evolving asymmetric threats. 3. Increased global competition. The development of laser weapon systems is not exclusive to the U.S. Nations such as Israel, South Korea, China, and the UK are rapidly advancing their own capabilities. This arms race in directed energy technology will lead to increased competition for superiority in naval warfare, prompting nations to invest heavily in research and development. As countries enhance their laser weapons, the landscape of naval engagements may evolve, with lasers becoming a standard component of naval arsenals. 4. Challenges and innovations in power generation. While HELIOS offers significant advantages, challenges in power generation and atmospheric conditions affecting laser effectiveness persist. Future developments will likely focus on improving shipboard power systems to support high-energy weapons and enhancing laser performance under various environmental conditions. Innovations in energy storage and generation will be crucial for maximizing the operational viability of laser systems. 5. Transforming engagement protocols. The introduction of HELIOS will necessitate a reconsideration of engagement protocols in naval warfare. The speed and precision of laser weapons will enable rapid responses to threats, changing the dynamics of engagement. Naval commanders may adopt more aggressive postures using lasers to deter potential adversaries before conflicts escalate. This shift could lead to a new era of naval deterrence, where the mere presence of advanced laser systems influences adversarial decision-making. 6. Enhanced joint operations and interoperability. The integration of HELIOS with existing combat systems like Aegis will enhance interoperability among allied naval forces. Future naval operations may increasingly involve joint exercises where multiple nations deploy laser systems in coordinated defense strategies. This collaboration will promote the sharing of best practices and technologies, ultimately strengthening collective defense capabilities against shared threats. 7. Impact on asymmetric warfare. The scalability and flexibility of laser systems like HELIOS will be particularly advantageous in asymmetric warfare scenarios. As non-state actors increasingly employ drones and small craft in conflicts, laser weapons provide an effective countermeasure. The ability to engage these threats with precision at a lower cost per engagement than traditional munitions will be a game-changer in such engagements, allowing navies to maintain dominance without depleting resources. 8. Long-term strategic implications. The proliferation of directed energy weapons will have profound long-term implications for global military strategy. As nations invest in advanced technologies, the balance of power may shift, with laser capabilities becoming a critical component of national defense strategies. The strategic calculus of military engagements will evolve as nations equipped with high-energy laser systems may deter conflicts through their mere presence. 9. Potential for non-lethal applications. In addition to their combat roles, laser systems like HELIOS may find applications in non-lethal operations such as crowd control or disabling enemy surveillance without causing destruction. This versatility could lead to a broader acceptance of laser technology in various military and law enforcement scenarios, expanding its utility beyond traditional combat roles. 10. Ethical and legal considerations. As laser weapons become more prevalent, ethical and legal considerations surrounding their use will emerge. The potential for precision strikes, reduced collateral damage, and non-lethal options will spark debates about the implications of deploying such technologies in conflict zones. International norms and regulations may evolve in response to the growing presence of laser systems, shaping the future of military engagement. Conclusion. The integration of the HELIOS laser weapon system aboard the USS Preble marks a transformative moment in naval warfare. As the U.S. Navy and its allies continue to explore the potential of directed energy weapons, the implications for naval strategy, global military competition, and the future of warfare are profound. The ongoing advancements in laser technology will redefine how naval forces approach defense deterrence and engagement in an increasingly complex security environment.